So what's left? Well, we don't yet know how to take the derivatives of exponential functions and log functions. So let's take care of that right now. Here's a cool thing. The derivative of e to the x is e to the x. So e to the x is its own derivative. And back when we first introduced e is the natural exponential base, I said there was a reason why it is the natural base, and the fact that e to the x is the function that its own derivative is a big part of that. So that's really, really quite cool. And for the natural log, the derivative of that is 1 over x. Okay, so they're both kind of nice, simple derivatives. Those are two good facts. We use these rules a lot in combination with the chain rule. Okay, so let's write out what we'd have there. So if we have the derivative of e raised to some function of x, we've got something fancier up there in the exponent than just x. It's just the derivative of the inside times the derivative of the outside. Okay, so the chain rule idea here is this is e to the, we could call it y here, and that is just e to the y times the derivative of y with respect to x. Okay, so derivative of the inside times the derivative of the outside. And we do the same thing for the derivative with respect to x of log f of x here against the derivative of the inside times the derivative of the outside. Okay, so same story. We're taking the log of a thing. We could call it y. The derivative of log y is 1 over y. The derivative of y with respect to x here is just the derivative of the inside there. Okay, so we've got the sort of basic facts about the plain vanilla version of these functions and formulas for how to use them along with the chain rule. I'll do a quick example of each. I want to make one comment about the log of some function here. That is only defined when f prime of x is greater than 0. Okay, you can't take logs of negative numbers or 0. And this domain restriction actually ends up helping us sometimes when we're using the kind of generalized log rule. Okay, so let's just do a quick example on the exponential function. One thing we could do with the chain rule version of it is we could take the derivative of some other base raised to the power x. So if we had a function like 2 to the x power, we could just do what we were doing in the previous unit and rewrite 2 as e to the log 2 times x. Okay, so here's our 2, and we're still raising it to the x power, just using those rules of exponents there. And so now we're taking the derivative of e raised to x multiplied by the constant log 2. So that is just the derivative of the inside here is log 2. So linear function of x in the exponent there times the function itself. And we wanted to rewrite that as log 2 times 2 to the x power. Either way, it's fine. Let's look at another example here. So if we have f of x is the log of 4 minus x squared. Again, we're going to take the derivative of the inside. The inside function is 4 minus x squared. That's our numerator of the fraction, negative 2x, divided by the derivative of the outside. The outside function is the log of a thing, and the derivative of that is just 1 over the thing. And here the thing is 4 minus x squared. But as I was saying before, this function is only defined when the denominator is positive. Okay, so we need to have 4 minus x squared greater than 0. We could work out what that means for the domain. It means that x has to be between -2 and 2. But even without taking that step, we know that this must be positive. So the punchline here, the sine of f prime of x over f of x in these cases, let me not write it that way. The sine of, let's really say what we're saying, the derivative with respect to x of log f of x depends only on f prime of x. And this, using the rule, is f prime of x divided by x. Okay, it's the derivative of a log of a thing. Derivative of log of x. And just use another color to emphasize that this is always positive if we are taking its log. Okay, so if we want to find the sine of a derivative, we want to find that sine of a derivative, and that's a derivative of a function that might have kind of a hard derivative to take. If it's easier to take the derivative of the log of that function, it will have the same sign. Okay, so if we want to avoid using the product rule because it's complicated and we hate it, and all we care about is the sign of the derivative, we can find the sign of the log of that product. Because it's a log, then the log of the product becomes the sum of the logs, and we can find the derivative of the sum easily. The addition rule is easy, and the sign will not be affected. The sign will just depend on the derivative of the function that we started with, the derivative of the inside function. Okay, so that's the third of 3 lessons on taking derivatives. You guys are in great shape now to take a ton of different derivatives. This unit has one more lesson on second derivatives, so I'll see you in that one.